What's up, everybody? I just got done with spring break, and so did most of you, and hope you had a good time. Today, we're starting a whole new chapter in our lives, chapter number 10 of 7th math level here, but I thought we'd start off with a joke. Why not, huh? So here's a joke for you, a little math joke. Why wasn't the geometry teacher at school today? Why wasn't the geometry teacher at school? Well, the answer is because she sprained her ankle. So, hope you like that. Hey, we're talking about areas of parallelograms and trapezoids, and to prepare for today's amazing presentation, I made you a little parallelogram of your very own. What makes a parallelogram a parallelogram? Well, it's got two pairs of sides, opposite sides that are parallel. So there's one pair that are parallel, there's two pairs that are parallel, right? This is a parallelogram. Now, we're talking today about area of a parallelogram. Let's not be confused. We are not talking about the distance of a side or the perimeter, the distance around. We're talking about how much space is this. I don't know what color that looks like to you. To me, it's like a purpley pinky. How much space is purpley pinky here taking up of the screen? What's the area it's taking up? You couldn't say, oh, it's taking up about an inch. What does that mean? Like an inch is just a line. You could say it's taking up about 1 square inch. Oh, okay. So remember area, we're talking about square units. All right. Well, let's get right to it. I want to see if I can get through to some of you right now. A lot of what we've been doing in math, the skills that we work on as far as how to solve for a variable, what to do when there's parentheses, what to do if there's fractions, and how to solve equations. A lot of that is setting us up to be able to work with, drumroll, formulas. Formulas solve many problems for us. There are formulas to find the area of a square, for example, and you probably know that formula. That would be side times side. Or the formula to find the area of a rectangle. Okay, this is very helpful. I want to know how much it's going to cost to repave this this parking lot out here, and I got a company that's going to do it, and they say, "What's the area?" I say, "Oh yeah, that's length times width." Oh, so I measure it or whatnot, and I say, "Oh, it's about 1,000 square feet. It should be 100 by 100. That'd be a small parking lot. Anyway, 1,000 square feet. You got to know how these formulas work. Now, what's cool is there's formulas for how much thrust a rocket needs as it's landing on the moon, how much thrust there needs to be at first, and then steadily slow down so that it'll have a safe landing on the moon. There's formulas for how, like, maybe a jet taking off an aircraft carrier. There's formulas for all types of things you can't even imagine right now that you don't even know about. I don't even know about. There's formulas. So today, that's all this is. It's two easy basic formulas for the area of a parallelogram and the area of a trapezoid. Just simple shapes. But it's so much more than that. It's how to understand what a formula is and plug numbers in and find the unknown numbers, find the answers. So, let's get to it. Today, to find the area of a parallelogram, and this is moving as I'm breathing, all you have to do is take a base, that would be this whole length right here, the base times the height. Now, if you're, I don't know, how do I explain this? The height is not the distance of this side over here, okay? Oftentimes we'll call that the slant height because that's slanted. The actual height of this parallelogram, if I'm a little dude standing right here and I say, whoa, check out this big old parallelogram, and I'm looking like I'm going to hug the parallelogram, the height of it is not how tall this slant is, it's actually perpendicular to the base. It would go straight up like that. And I don't know why I'm using a red pen. Sorry about that. Where is my nice pen I like? I guess I'll use this one for now. It's perpendicular to the base. So if the base here, let's say, is 10, okay, and the height, which is perpendicular to the base, is, that looks like a little less, so 9, all you have to do to find the area of a parallelogram is literally just do the base times the height. 10 times 9. Okay? Not very hard. I'll show you how it works here. If I cut, in fact, I might even do that real quick. Before I cut it though, let me just explain one more thing. So 10 times 9 is 90. 90 is the area of this. 90 square centimeters, we'll say. But check out my parallelogram here. Is this one the base or is this one the base? Well, it just depends on how you have it oriented. Okay, right now, this one's the base, and the height is going to be perpendicular up to the top. Okay, but here's how that formula works. It's just base times height, because watch this. I'm take my scissors. I'm going to cut that triangle off. I'm going to re-put this the way we had it before. So there's 10 and 9. That's no longer 10, is it? Because I cut off this piece right over here. I cut that piece off. I'm going to take this piece and I'm going to put it right over here, cover myself up, and it should be like a perfect fit. And now, is this whole base 10? Yeah, because that was just over there. So this whole thing is 10. Is the height still 9? What shape is this now? It's a rectangle. So really, area of a parallelogram is just length times width. But the width is not some outside slant height like that. The width, we actually talk about it being the height. Base times height. It's perpendicular. So that's how that works, and then your book will tell you kind of in words what that looks like. Base of a parallelogram, height of a parallelogram, and they cut off the little triangle down here so you can see that trick, what I just did. And so there you have it. A very simple formula. Area equals base times height. Now what if I tell you, okay, that's pretty easy. If the height is 3 and the base is 5, what's the area? 15. 3 times 5 is 15 centimeters squared. Centimeters squared. Ooh. Which, if I didn't tell you this in class earlier, which I have in my notes to tell you, units, this chapter, will matter. You must write your units for any problem that has units. Units, what are units? Units are meters, centimeters, 50 pies, 20 cows. What are your numbers talking about? Okay, inches. Those are all units. They're mattering this chapter because you need to understand that a centimeter is different than a square centimeter. So notice here, if this is 3 centimeters tall, a straight line, and this is 5 centimeters long, a straight line, multiply those two dimensions together and you get a two-dimensional thing, which is area. And that is centimeters squared. Do not do 15 times 15. It's not 15 squared. It's just 15, but the units are squared. Square centimeters. Okay, so this is pretty simple. So we'll just breeze through this example. Let's say the area of this is 20 meters squared. And the, should I try something? Well, we'll say the base is 5. What is the height? Well, write your formula. A equals B times H. Now just plug in the numbers that you know. I know the area is 20. I know the base is 5. I don't know H. Divide both sides by 5. What is H? It's 4. 4 what? Is it 4 meters or 4 meters squared? I hope you said 4 meters because this is actually just an actual length here of the height, isn't it? Area is square meters. This is just 4 normal meters. Alright, so that is the area of a parallelogram. Let's get on with the next guy. and this is area of a trapezoid. Now, with a trapezoid, which is what I have here now actually, check this out. Is my purple shape a trapezoid now? What is a trapezoid? A trapezoid has exactly one pair of parallel sides. And they don't say that up here because you should already know that. Exactly one pair of parallel sides, and it's a quadrilateral. So, is this side over here parallel with this side? No. But the top is parallel with the bottom. So this has exactly one pair of parallel sides. These two aren't parallel. Now, when you have a trapezoid, there's two bases. We call those two sides that are parallel, we call those the bases. So this is one base up here at the top. This is another base here at the bottom. All right? And then the height is still just the distance between those two, perpendicular. Okay? So look at this trapezoid in your book. Base 1, base 2, height, and here is the formula to find the area of a trapezoid. Area equals 1/2 of base 1 plus base 2, all in parentheses there, all of that times the height. Now what they're showing you up here is that if you take one trapezoid and you duplicate it and stick another one right next to it like that, that means you have a base 1 and a base 2 for the base of the bottom. You have a base 2 and a base 1 for the base of the top. So if you add those two together, you have one big base times one big height, and that would give you the area of this whole parallelogram. And then you just cut that in half, which is where this half comes from. So we've got base 1 plus base 2 times the height, and then cut that all in half right there, and that gives you the area of just one of the trapezoids. So that's how they came up with the formula. Kind of cool. So down here, here's your formula. Let's just do a couple example problems of how to use that formula, and we'll be off. The Winslow house was designed by Frank Lloyd Wright, and I'll show you a picture of the Winslow house. There it is, apparently. The front part of the roof is a trapezoid. What is its area? Okay, so we've got 31 feet up here, 77 feet down here, 25 feet is the height. Do you have it memorized yet? It's sticking up here. Add the bases together, 31 and 77 in your head. That would be 108. 108. Now, do we need to do 1/2 times the 108 next? Or do we need to times the height next? Does it matter? Please tell me you know. That would be 1/2 times 108 times the height. If they're all times, it does not matter which order you do it in. So they do 31 plus 77, so that's 108. Let's do 1/2 108, because I can do that in my head. 1/2 times 108 is just 108 divided by 2, and that is 54. Then you got 54 times the height, which is 25. Boom! 1,350. Oh, but we need to put the correct units. The front part of the roof has an area of 1,350 square feet. All right, cool. But what if they did this to you? What if they said, hey, this trapezoid, why do we always draw them that way? Let's do it like this. Like that trapezoid? All right. What if they said this trapezoid is 13 on the top here, and this is 7 on the bottom. What is the height? And the area, by the way, I've got to give you that, is 250. I'm not putting units right now, just for time's sake. Write the formula. Area equals 1/2 base 1 plus base 2 times the height. Okay, plug in what you know. Area is 250, so I'm going to put 250 for the A, equals 1/2. Base 1 plus base 2, 7 plus 13 is what? 20 times height. What is 1/2 of 20? 1/2 of 20, 1/2 times 20, 1/2 of 20 is 10. 10h. Divided by 10, both sides. Hey, this is a good example here. 250 divided by 10 just means take off a 0. And we're left with 25 for the height. That's working backwards. If you're given the area and you need to find the height, we need to find the base. All right, I think you should be fine with that. I hope this comes easy to you. If not, put the effort out to figure it out and get good at it, because you will be given more and more formulas in your math career, and maybe even in your career, where you can figure out much needed information. Might not always be the area of a shape, but it might be the amount of carpet I need to buy for this this room that I'm doing, or the amount of if I can get away from area here for a second, the amount of little packing peanuts that we need to buy for our company for all the shipping that we're doing. Formulas for everything. Someday, in fact, I have a student this year who, just for fun, was making a formula of his own. I can't remember what that was for. So anyway, someday maybe you'll make your own formulas. All right, have a good time.